Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about this. The salt of the compounds need to be soluble. It means that they need to be able to dissolve in the solvent. For example, water. Yes, it must be able to dissolve. The suitable soluble salts of zinc and the copper are, for zinc, it's better to use zinc nitrate. When you're talking about the chemistry of nitrates, all nitrates are soluble. They are able to dissolve. And the copper nitrate, So these are the solutions. So on the side of the half cell of the zinc, you put zinc nitrate solution. And on the side of half cell of copper, you put copper nitrate solution. That's what it means. So in here, zinc nitrate solution, and then in here, you put copper nitrate solution. Now someone will ask you, but you talked about copper sulfate. Yes, but they are saying the suitable. You can use any other, but the suitable, the one which is much more better is that zinc is oxidized to zinc ion. You know that? And the concentration of zinc ion increases. Now look at this. How is the salt bridge very important? Let me just open your mind so that you know where we are going. Zinc is oxidized to zinc 2 ions. The concentration of zinc 2 ion increases, yes, building up a positive charge. So the concentration of zinc ions here, yes? Yes, they increase because it dissolves here. The electrons will move away from the negative potential. Remember, this is a negative potential. And then it goes to where copper is here. They go. When they go, they come this side to copper. What happens? The electron will move away from the negative potential, yes, the terminal, making it impaired. It means that now we have too much positive here. Remember, this is supposed to be a negative terminal. And then now you have too much positive. What will happen? Then it's going to be impaired. We need something which is going to neutralize this. This is a negative terminal, but now the positive charges are building there. So what is supposed to happen? Yes, we need to keep it negative, because if you don't keep it negative, it's going to turn into a positive, and then the reaction is not going to take place. All right. So copper 2 ion. So what is happening to this? We're going to look at the solution for this. But copper 2 ion are reduced. When they are reduced, they form copper solid. Wonderful. Then you are saying that the concentration of copper 2 ion decreases. It means that now when it comes like this, these electrons, they react with copper 2 ion. Remember I told you that now it starts to fade. Yes? Because we have used all the copper 2 ions. So the concentration of copper 2 ion decreases. This leads to copper 2 becoming less positive. It becomes less positive because now the positive charges have been used up. It has formed a solid. And remember, this is a positive terminal. So if the problem comes in now, what is happening really? So we have to make sure that this one remains positive. The electrons are therefore not attracted. It means that now these electrons from this side of zinc will not come to the copper. Why? They are no longer attracted. Why? Because now the copper 2 ions have been used up. It's no longer that strong positive side. Then what happens? Attracted to the cathode as strongly, making it impaired. It means that it can't work anymore. So what happens? We have to look for a solution for impairment of the cell. So what should we do? Number one, we are saying that the migration of nitrate anions is a negatively charged particle. Yes? Negatively charged particles are called anions, and positively charged particles are called cations. So we are saying that the migration of nitrate anions in this salt bridge to the anode. Remember, we say that here, this one becomes it forms this, yes? And then it becomes more positive. It reduces the negative part of it. So what we need to neutralize this. So because it is positive, zinc 2 ions, yes? What is happening? the zinc 2 ions have accumulated, so we need a negative anion. Where is it going to come from? It's going to come from the salt bridge. Potassium ion, remember it is made up of, the salt bridge is made up of potassium nitrate. Yes, in the salt bridge to the cathode. So it means that this one will go to the anode, while this one will go to the cathode. Yes, it is potassium nitrate in the salt bridge. So what happens? It means that the positive will go to the copper, and then the negative will go to the zinc. Let's go back here and we see. We say that this one accumulates. When it accumulates, it forms more positive. So we need to reduce it so that it goes back to a negative terminal. So we send it potassium, we have potassium nitrate. We send here the nitrate. So it neutralizes this. So it means that now this terminal remains negative. Now here, when this one comes in, when it comes in, it uses these copper 2 ions. When it uses the copper 2 ions, oh, what is now happening? It's gonna make it lose its positive ability. Yes. So what do we need? We need a positive charge to come here. Remember, it is potassium nitrate. The nitrate has come here, and the potassium is positive. So the potassium will come this side, and then makes this one to be positive. So it means that now the terminal will be able to attract more electrons, more electrons. That's it. That's how you can explain. You're saying that this cancels this build up of undesirable charge, maintaining the cell's electric neurality. It means that it will be neutral. There will be no more this fluctuation in the polarity, and the negative will remain negative. That is the function of the salt bridge. That's why we say that it brings about what you call neutrality. All right. So we are saying that the cell, therefore, continues to form or to function properly. It is going to continue functioning properly without any problem. Electron current. Let's look at it now. Electrons are always moving from anode, from the negative terminal to a positive terminal, from zinc terminal to copper terminal, through an external circuit to the cathode. So it moves from the anode, zinc, to the cathode, which is copper. Then you're saying that in copper zinc cell, electrons therefore flow from zinc to copper. I've tried to explain that. It means that it moves from a more reactive element, which is able to be oxidized, to a less reactive element, which is able to be reduced. Cell notation. How do we write now the notation? How do you write the notation? Always start with the anode, which is the negative on the left, and end with the cathode on the right. Cathode is the positive. Are we there? Anode, negative, cathode, positive. All right. Use this separator. Use a dash. Use a dash. Use this to separate anode or cathode. I'm gonna show you. From its electrolytes. Represent the salt bridge. The salt bridge, when you use this two double slash, forward slash, because you have a back slash and a forward slash. The two forward slashes, yes, it means that you are representing a salt bridge. When you use one slash, it means that you are separating anode, or you are separating the cathode. Components of the cathode and components of the anode. For example, zinc, which is a solid, slash, it means that it gives out zinc 2 ions. It means that it is oxidized, which is aqueous. Then I have a salt bridge, yes. Then the copper receives the electrons from zinc, remember? And then you have copper 2 ions. When it receives the electrons, then it is reduced to copper. Then I have to separate it, that this copper give me copper solid. That's how you're supposed to explain it. Let me repeat. Zinc gives me zinc 2 ions, and then the copper 2 ions gives me copper solid. That's the meaning. What happens in the half cell of the zinc, what happens in the half cell of the copper? Electrode, this is the electrode, yes, slash the electrode, the solid dissolves into what? Into electrolyte. Electrolyte, it means a solution. Electrode, it means a solid dissolve into the solution by giving the ions, yes. Salt bridge. Now, what is in the solution? The copper 2, yes, which is the electrolyte solution. It gives me, or it gives the electrode, which is a solid. You understand? That's how it's supposed to be interpreted. Or you can say, this is what needed, but these ones are trying to explain. Anode, which is a negative, salt bridge, cathode, which is a positive. That's it means. All right. Here is what we are talking about diagrammatically. Zinc gives me zinc 2 ions. Yes. Zinc gives me zinc 2 ions here. Yes. Then I have copper. Copper 2 ions gives me copper. Is this? And then you have in between here, I have a salt bridge. Salt bridge which connects them. That's the meaning. Unless you have a question, next time we're gonna start with the standard electrode potential. Standard electrode potential. Make sure that you come to class on time.